This time, I'm going to talk about support vector machine in Python. In machine learning, support vector machines are supervised learning models. That means we have our data and we knew which categories all those data belong to. And we will supervise the model and use the data to train the model. And the model has associated learning algorithm that analyze data used for classification and regression analysis. Support vector machine uses a technique called the kernel trick. The kernel trick can transform your data, and then based on those transformations, it will find the optimal boundary between the possible outputs. I will explain in detail later. Let's check out those two categories of data. One category is the circle, and another category is the square. So we want to draw a line to separate all those two categories. So which line we should draw? So the main idea is to find an optimal plane between all those data. So this optimal separating hyperplane is the one that correctly classifies all the data while being farthest away from the data points. See this plane, it separates all those two categories, and also it has the maximum margin between all those two groups of data. So we should use this hyperplane to separate the data. As I mentioned before, in SVM, there is the kernel trick. Let's check out those data points. All those red squares clustered in this area, and around all those red squares there are many green circles, and if we can transform them to this three-dimensional shape, we can use this surface to separate them. That is, if we consider the distance between the data points and the middle point of the red squares, and we put higher weight to the closer data points, and then we can transform the two-dimension data to three-dimensional data. So this SVM kernel is a function that takes low-dimensional input space and transforms it into higher dimensional space. And it is most useful in nonlinear separation problem. Let's check out the SVM kernels in Python. There are many SVM kernels available in Python. I will only use linear kernel, polynomial kernel, and RBF kernel for this demonstration. The linear kernel is when we try to separate all those three groups of data, and we just use a straight line to separate them. And when we use the RBF kernel, we can separate them with those curves. You see, this is group 1, this is group 2, and those green area is group 3. And in this condition, with all those data, we have a similar result. That is, we can either use linear SVM or RBF SVM. We can all separate all those data. But for certain circumstances, for example, this one, we have one group of data clustered in the middle here, and the second group surrounding the group 1 data. And if we use linear SVM, there's no way to separate them successfully. And then, under this condition, we need to use nonlinear SVM. For example, we can use RBF SVM and then separate them use this circle. So within the circle is group 1, outside the circle is group 2. Now let's take a look at the SVM function in Python and its parameters. In Python, we will call this function to perform our data analysis. There are 3 parameters in this function. The first parameter specifies which kernel we want to use. Here, I say kernel equal to RBF. And we have second parameter is C, and third parameter is gamma. So when we use RBF kernel, those 2 parameters, C and gamma, must be considered. The parameter C is common to all the SVM kernels. What does it mean? So a low C makes decision surface smooth, and the high C aims at classifying all training examples correctly. That means lower C will lose the condition, and the higher C will put very strict condition on classification. So if C is too high, it might cause issue of overfitting. Then what is gamma? Gamma is used for nonlinear model. So if we use linear kernel in SVM function, gamma doesn't do anything. When gamma is small, a low value of gamma will loosely fit the training dataset. When gamma is very high, it will try to fit the training dataset exactly. So in that case, it might cause overfitting. Now let's take a look how do we implement that in Python. In this video, I'm going to use the dataset in Python about flower iris. Let's see what kind of data we have. You can see there are several characters about the flower, and there are categories about those flowers. So we have label 0 means group 1, and label 1 shows group 2, and 2 shows group 3. So we know how to categorize all those flowers already. That's why we are saying SVM is a supervised model. In order to display the data and the result on the screen, I only pick up two characters about the flower, the sepal length and the sepal width, so we can draw. Otherwise, if we have 4 parameters, it's difficult to draw on the screen. At the beginning, I put C as 1 and gamma as 0.1. And then if we run the linear kernel, you can see we have data here. Obviously, we have some crossover among all those data points. Say all those orange circle and the brown circle, they mixed. But with this linear kernel, we can separate them like this. We say, okay, this is group 1, this is group 2, this is group 3. How about the polynomial model? If we run with the polynomial kernel, and we can see we got a similar result at the linear kernel. This is group 1, group 2, and group 3. So how about RBF kernel? Again, with RBF kernel, we got similar result. So this is linear kernel, this is polynomial kernel, this is RBF kernel. This is when we run all those models with C equal to 1 and gamma equal to 0.1. As I mentioned, C, when we increase that value, it's trying to put strict condition to the fitting. For example, with the linear kernel, if we put C as 100, this is C equal to 100, and if we compare with 1, you see this is 100, this is 1. Really didn't change that much. How about the RBF kernel? And also, by the way, the polynomial kernel, you can think this is nonlinear kernel, but it's kind of between the linear kernel and the RBF kernel. So in this video, I'm going to demo RBF kernel mainly. Okay, let's switch to the RBF kernel. And then, as I showed before, when C equal to 1, gamma equal to 0.1, it shows a result like this. And then, if we put C as 100, you can see it has group 1 here, group 2 here, and group 3 and group 3 here. This is because C is too big and it is trying to fit all the data points. It will generate overfitting problem. And if we put C back to 1 and increase gamma, say if we say gamma equal to 100, we run that, you can see because it's trying to fit all the data points, it has a lot of small groups, and obviously this is a problem, our overfitting. And if we put gamma as 10, you can see all those area will connect. And if we put gamma at 5, and then you will see it will change gradually. And eventually, if we put back gamma at 0.1, it will generate results similar to the linear kernel. So when you analyze your data, it is very critical to decide the C amount and the gamma amount and try to fit your data well, but not generated the problem of overfitting. This is why we use support vector machine and how to implement that in Python. Please provide your comments and subscribe to my channel. Thank you very much for watching.